So, good afternoon, everybody. I apologize for being a few seconds late. Honestly, YouTube Live just decided not to load at the very beginning. Um, so, the lecture today was all about sorting and custom sorting in both Python and JavaScript. So, that's what we're going to be talking about today, demoing today, answering any questions that you might have today. As always, this video is going to be recorded, so if anybody wants, you can go back and watch everything that's going on. In addition to that, I will be posting links to the Replit sites. There's actually two of them, one for Python, one for JavaScript, later on. So just to start, what I want to do is just get into this process of sorting. We're going to start with Python. Just now, it's the one that's open. So what I have here is a list of strings, right? So some of you may recognize this list. It is frankly the bars on a treble scale. So lots of different ways of doing it. Every good band deserves fun was the one that I learned. Lots of different examples of this. But now we can sort a string or a list of strings. That's not a problem at all. If we wanted to do that, what we're going to do is we're going to use this sort function. So we have the variable .sort. And now with strings, by default, it's going to use alphabetical ordering. So for many of you, probably this is something you're familiar with. I know that for some of you, particularly if you are a native speaker of a language like Chinese or Japanese, or some of these languages which do not have an alphabetical ordering, this might be a somewhat new idea, though hopefully not too much. And the idea behind alphabetical ordering is that when we sort things, we're going to use the alphabet to do that. So by default, we start with the first letter. And so since B is the smallest letter there, we should see once we run this, and I will run it right now, that we get, band deserves every fun good, B, D, E, F, G, which is the alphabet, right? And so note that afterward, it prints out this word none. And the reason for this is because of how I did this. So you'll note that I actually have two variables here. I have treble, which is our list, and I called treble.sort here. And I also assigned the result of calling treble.sort to a variable that I very cleverly named, please don't do this. The reason I named it that is because it's really important that you not do this. The sort function in both Python and JavaScript is an in-place function. So it uses the fact that a list is a mutable data structure. So we've talked about this before, but remember that when we say something is mutable, that means its contents can change. So when we call sort, it actually sorts that list automatically, right? If I just do this the proper way, call treble.sort, note that the result when I print out treble is that the order of its contents has changed. It's automatically been put into sorted order. I do not need to use a return value. And in fact, as we saw before, if I try to look at that return value, I'm going to actually not print treble this time just to make it more clear. The result is none. That sort function doesn't return anything. So you want to make sure you never, ever, ever try to do this. Now, I realize for those of you who are watching this video or listening to this video right now, probably you're not very likely to, or you make a mistake, you'll fix it pretty quickly. But this is a very, very common mistake. So one other thing just to point out, when we do this alphabetizing, get rid of this because that's a bad idea. Actually, one of the things to remember is this is a computer. It still does have an IQ of 0. So if we do something unusual, actually, I'll change the D. Note that I'm going to replace that D with a lowercase d. What's going to happen is it's going to, again, do its alphabetizing from smallest to largest. And the lowercase letters appear to occur after the uppercase letters. So that lowercase d does not get sorted into the order where the d's are, but into the order where the lowercase d's are. So, it is actually just using the way it has its numbers encoded to do this. So, that's the first sort of example. I'm going to actually comment that out. Actually re-add this just to make it clear not to do it. And now I have the second example. And again, just to show you how this works, the second example creates two different lists. I have count, which has the ints 5, 4, another 4, 8, and 3, and count but stir, which again is a list, but it has now the string versions of those. And if I run this, you can see that both of them work perfectly well. For Python, if we have a list that has some numbers, it sorts in numerical order. If we have strings, note that the results here have a 3, a 4 inside of quotes. It does it perfectly well. We can still use that sort function, but it does it in alphabetical order. And just to make this a little bit clearer, hopefully, I'm going to do the same thing. I do not know why I have this line twice. With two different lists. I have one list, natural, which, like last time, has numbers, has ints, 50, 400, 43, 8, and 3. And then I have another one, natural-ish. Get rid of this real quick just for the first time, which has those same numbers, 500, 400, 50, 400, 43, 8, and 3, but note that they are strings. So again, I'm going to call sort on each one of those lists. Common thing to do. But you can see that the results are not the same, right? When I had count and count but string, the results were the same, just whether one was a string, one wasn't. Here, natural, that first result is 3, 8, 43, 50, 400. It's in increasing order. Natural-ish, the second thing is 3, 400, 43, 50, and 8. It's not in numerical order. So anyone have an idea why this difference exists? Just type it out into the... See if anybody can come up with an answer real quick. Okay, I don't see anybody having an answer. So the reason why these are being sorted differently is because of their data types. Remember that all of us, you guys, me, are human beings. We have an IQ over 0. And so we can tell that all of these strings here contain numbers. All of us want those to be ordered numerically because that's clearly what was intended. The computer still has an IQ of 0. It says these are strings. I'm going to compare them. I'm going to sort them using less than, greater than. And with strings, that means do it in alphabetical order. If you look, what we have here is alphabetical order of these strings. 3 comes before 4. 40 comes before 43, again, alphabetically, because a 0 is smaller than 3. A 4 comes before 5, and all of these come before 8. So when we have data that is a int, Python sorts it numerically. When we have data that's a string, Python sorts it in terms of strings, in alphabetically. So one last sort of thing to think about is what happens if we have data that is a mix of strings and ints. So here I have 4 strings in this list, 50, 400, 8, and 3, and 1 int, the number 43, the int 43. So anyone have an idea? Anyone want to guess what the result is going to be? So I'm going to call sort here and then print out that result. Anybody have a guess what's going to happen? Okay, again, I don't see a lot of responses. I see that there are people watching. So we can try it out, right? One of the nice things about computers, one of the things that you guys should always try to do is test these ideas out. What happens if you actually use it? So I'm going to run this program now. And you can see it's going to give me an error. The error it gives me, right, is it's saying on line 22 for this line naturalish.sort. So it's saying that it can't sort the data. And the reason it's saying it can't sort the data is because, remember, if we just use sort by default, well, it's going to use that, greater than or less than operator. In this case, the less than operator. And of course, we can't use the less than operator when we have both strings and ints. We need it to stay as one type of data. We can't mix it using the natural version, the default version of sort. And this actually gives us another problem. So here I have another list. If you look, I have a list here. It begins with a brace, ends with a closing brace, right? But each entry in this student's list is a dictionary. And now this is a very, very, very common thing that we do in computer science, in computer engineering, right? A lot of times when we're working with data, we don't just have numbers, we don't just have strings, but we have things that combine numbers and strings. So you can imagine this might be like the records in some student listing, right? Where every student has a first name, a last name, a person number, and for this example, an age. So both strings and numbers, right? This is key value pairs. And again, if we try to run this, we get an error. By default, Python has no way of knowing how to compare two dictionaries. It can't use that less than or greater than operator. If we want to be able to see what happens, to order what happens, we need to tell Python how to order each thing. And so this is where custom sorting comes in. Python has a actually relatively simple way of doing custom sorting. So for this first example, I'm just going to create a simple key selector function. This is what Python uses. And the key selector function, it's just a function. The function has to have one parameter, and then it should return a value. And the value that it returns will decide how data should be sorted. So to give you an idea, we'll just do this for both of them. Going back to my example from before, I've created this function selector, and all it's going to do is it says, well, give me an input, and I'm going to return that input as an int. Now, I have two different versions of this list here. I have natural. Note, for natural, the data are already ints. So we can use that selector function. It just won't do anything, right? It's not necessary, but it will still work. Here I have that list natural-ish, which, as you may recall, has numbers. It has ints, but they're not stored as ints. They're stored as strings. And before, when we just called sort, it alphabetized them. So here what I'm going to do is I'm still calling that sort function. I'm still not using that return value. It's still going to be done in place. But for an argument, I'm going to have key equals, and this is a way of doing a named argument. So we said the argument is named key, and then I have the equal sign, and then I have to specify the name of my key selector function. So here I say selector. And now what's going to happen is Python is going to automatically call that selector function on each of the entries in my list. And the result that that key selector function returns is going to be how it decides to order things. It's going to use those return values, sort of order those return values, and duplicate that for this list. So if we run this, you can see that natural is in numerical order. That makes sense. That's what happened before. But note that natural-ish, which before was getting into alphabetical order. In fact, I could redo this and just say what happens if we do. Right? If we don't use that key selector, it does order them, but it orders them alphabetically. When we use that key selector function, that's the second line here, right? Key equals selector. Get rid of this just to make it clear that I was using it that first time one way, the second time a different way. Now, what it does is, in order to sort them, it first calls that key selector function. So it says, okay, for this string 50, I'm going to order it as if it were the number 50. For this string 400, as if it was the number 400. So that result is ordered the way that the numbers are ordered, the way that the selector returns that number. And this is actually something that we can use to our advantage. Comment this out real quick. What I'm going to do is define another key selector function, but slightly different. So this one, note I called it reversal, and it's going to take in an entry and return -1 times that value of that entry. So if I use this in my sorting, of course, what this means is that for 50, it's going to sort it as if its value were -50. For 400, it would sort it as if it's -400. And so the result, of course, is, now this is completely reverse order, because, right, if you think about what values reversal returns, this negative would be -400, which is smaller than -50, which is smaller than -43, and so on. By multiplying that result by -1, we can actually put numbers in reverse order. So one place, so that's one easy place for that. But one really useful way that we can use this is to order lists of dictionaries. So I'm going back to my example with all the students. You can see I've got lots of different students here. They have all this. Before, we said we couldn't use that sort function. We, in fact, couldn't use the sort function to order dictionaries. It doesn't have a natural ordering. If we use one of those key selector functions, then we can. So here is my key selector function. I called it LNAME ordering. And what it's going to do is return, whatever for each input it's given, it'll be for each of the entries in this list, it's simply going to return the value associated with the key LNAME. And so when I run this, what it's going to do, that sort function, and to make it work, again, I have to say key is assigned, and then I give it the name of my key selector function. It is going to be able to work and it's kind of hard to read because, there we go, it didn't like what it had to do. But if I move it over a little bit, you can see that the way that it's been ordered is in terms of their L name, right? So we have an F, then an M, then two different Smiths. So it actually is going to use whatever order they were in originally, then a W, then a Z. So if we want to order these records, these dictionaries, we can do that using this custom, this key selector. And now this is a very simple key selector. This just looks at the value in one field. What's the difference between natural.sort and sorted.natural? That is a good question. So actually, I'll be honest with you, I had not seen the sorted function. That's not the usual one I use. I think what sorted does, that's not what I'm trying to do. Let's just, so of course it's not going to work right now. I think sorted might again, I actually don't know. So here's what I'm going to do. In case you're curious how computer do this, I'm just going to look it up. So sorted is going to return a sorted list. So just looking at this, right? And note that it says returns a sorted list. So the difference between sort and sorted, as I wait for this to reload, is sort does the sorting in place. We're going to be able to say, here is the here is the list. Please reorder all of its contents. Sorted will sort things out, but it returns a second list. So for this class, we're only ever going to be using that .sort function. Typically, when we want to work with this, we want to sort the list in place. If you want, in other situations for other problems, maybe you want to keep the original list in its ordering for some reason and have a sorted ordering, you could use that sorted function. So hopefully that answers that question. I'm just double checking. But one thing to remember about this key selector process is it's not restricted to just using one value in the dictionary. So what I'm going to do now is I'm again using my key selector. Here I created this key selector function, full name ordering. It's a relatively thing. And what I'm going to do is rather than just using the last name or just using the first name, what I want to do is combine them. I want to sort people by their full name, have a proper alphabetical ordering. You can see before, right, when we were just using the last name, Sal Smith came before Fran Smith, even though F comes before S. So when we run this, what's going to happen is it's going to return a result, their last name, so in that case it would be Smith, then a comma and a space, and then the first name. And if we run this, you can see again, it's ordering them, but now Fran Smith comes before Sal Smith. It's going to order each entry, but rather than just using one thing, it's going to order them using the result of L name, comma, and then the first name. And in fact, when we're doing this custom ordering, we can select any values we want. We can use values that are in the dictionary. We could, if we wanted to, use something unrelated. I don't know why you would do that, but you could. We can choose anything that we want. Whatever we return, it's got to be a number or a string, something that we can compare using greater than, less than. But it's going to order the list as a result using that data. Now, this can be very helpful, right? This was a way that we could try to order full names, but realize it's not always perfect. So suppose, one last example in Python to show you the what Python can do, and also what it can't. I want to order all of my students, but I want to order them by their age, which is an int, and then by person number. So break ties using person number, which is a string. Remember that the way that these key selector functions work, I have to return a single value. The problem being that since age is a number and the person number is a string, there's not one obvious number or string that I could use. So what I did, the way I could think of it was, I said, well, what happens if we take that age, turn it into a string? That's legal. And then concatenate these. So when I do that, this is going to work, right? I just have to call that sort function, pass in, say key equals, and then the name. And you'll note that the name is really long here because sorting by age and then person number isn't necessarily immediately possible. And we can see that it does work in a way, just not the way that we want, right? So, of course, this is going to, this is not going to make it easy because I want to, so here's how I can do it. Right now you can't see the first option because it's hidden. So here's what I'm going to do is I'll actually print it twice. Create a couple blank lines, two different ways of doing a blank line, and then we'll print it a second time so we can see it. There we go. So you can see that when I've done it this way, it does order things using my key selector function. We just don't get the correct result. We don't get the result that we would like. And the reason why is that it's really difficult to combine these two different values into one thing that's logically connected for sorting. Since we're returning a string, everything is going to be alphabetized. And as soon as it gets to be alphabetized, we get this weird result, right? We start with the age. So 18 comes before 21, true alphabetically and numerically. 21 comes before 22. 22 comes before 23. 23 and 23, they're the same. But then we have this one student who's apparently amazing at UB and is there at age 8, made for a good example. And you can see that the 8, of course, that is alphabetically last. So even though we might want this student, Barb Woods, to be the first entry, the entry at index 0 in students, because we have to return a string to combine these data, we can't do that. Now, where this does work is if you look between, Sal Smith and Bo Zane, they both have the age of 23, so then we have to break the tie, and of course, their tie is broken using the person number ordering. So this can work, and there's no problem using Python to these key selectors if you have data that makes sense, but you have to have an easy way of being able to compare things. So any questions right now? So pardon me a second. I just saw something and need to really quickly be really rude. There we go. So I don't see any questions. So this is hopefully how we can do this in Python. One thing I didn't show here, but is also true, right? Just the same way that we can use this for lists of dictionaries, we could also use this for lists of lists. So if I wanted, I'll just do a quick example just to type this out. So here I'm going to create a list of lists. and print out the result. And when I do that, you can see that since this says return the result at index 1, well, if we look, this may not seem to be in any logical order, but of course, if we look at index 1 of each list, we've got a 0, then a 1, another 1, so those two could be done either way, and then a 5. So the same way that we can use these key selectors to help us sort when we have lists of dictionaries, we can do it for lists of lists. So we can also do this in JavaScript. JavaScript has the same sort of functionality. So just to go back to the very beginning, what I was talking about before, again, I'm going to create that. Now we're dealing with arrays because we're in JavaScript, an array of strings. JavaScript also has that sort function. So we can just call the variable .sort. And when we do that, again, just as we did in Python, that sort is done in place. When we call treble.sort, the result is the array in order. Unlike what happened when we were using Python, however, in JavaScript, the sort function does return a value. In particular, it returns the array in sorted order. So I again named the variable, please don't do this. And the reason I did that is because it's kind of confusing, right? We get one sort of behavior in JavaScript, one sort of behavior in Python. There's never a reason to use the return value from the call to sort. Both of them do it in place. It's a lot easier if you just never, ever do that and just rely on the sorting to occur in place. You'll see that in all of our code, all the examples that you ever see from the class, that's what we're going to do. So we can again do the same thing as before. Here I've got two arrays, one using, numbers, one using strings. Again, we can call sort on both of these. And as before, you can see they both come back in sorted order, or what seems to be sorted order. For the one of strings, the results are strings. For the one of numbers, they're numbers. So this seems all well and good, but there's a hidden catch when we're sorting in JavaScript. So here I have the same sort of idea, natural and naturalish. Natural contains entirely numbers. Natural-ish has strings. Now the strings are numbers, but they're all strings. So we can call sort. And if you remember, in Python, we got different results, right? The numbers were sorted numerically. The strings were sorted alphabetically. In JavaScript, as you'd expect, let me hit run. Oh yes, there. If you look, they are both sorted alphabetically. JavaScript sort function treats all data as if it were a string. If we want to sort data numerically, we can't just rely on the built-in natural sorting function. Instead, what JavaScript makes us do is similar to Python's key selectors. JavaScript provides what are called comparator functions. And so a comparator function is a function. It's like every other function. You can see one here. Here I have one I named numcomp. This is what we could use to actually compare two numbers and have them sorted as if they were numbers. What this is going to do, it's going to say if given these two, it'll convert them to numbers, use a greater than or less than. But the big thing about a comparator function is the actual number it returns does not matter. It has to return a number. The number itself does not matter. What does matter is the sign of the number. So if we want the first parameter, whatever the value of a is, to come after the value of b in our list, then we have to return a positive number. If we want a to be before b in our list, we have to return a negative number, any negative number. If they are equivalent, if they can appear in either order because it doesn't matter, then we return 0. So using this, I can take those two arrays before, natural and naturalish. Now, to use our comparator function, we again just make that call to sort. But now what we do is we provide an argument, and that argument has to be the name of our comparator function. So note it's not in quotes or anything else. It's just the name of the function. And so now when I run this, you can see we get the result that we would probably have expected normally. If we give it, whether we give it a number or a string, because it's going to compare them as if they're numbers, it's going to use that number function to turn them into a number and compare them, it actually orders them numerically. So whenever we are doing any sort of sorting in JavaScript where we want the results to be done numerically, we have to use a comparator function. So this is one way that we could write the comparator function. We could, of course, cheat. So one nice thing, and the reason we have this weird negative, 0, or positive outcome is to allow a certain shortcut. I can also write the code this way and just return the result of subtracting the two. When I do this, well, let's think about what happens. Suppose that A is smaller. Suppose that A is 4 and B is 7. Well, 4 is smaller than 7, right? We want 4 to appear first. We have to return a negative number. Well, what is 4 minus 7? 4 minus 7 is negative 3. A negative number. That will work. If they are equivalent, then of course when we do that subtraction, we get 0, the result for them being equivalent. If A is larger, then we're going to get a positive number. We're saying A should appear afterward. And in fact, I believe, double check, that we don't even need the number when we're doing subtraction, because subtraction is automatically going to assume that the result is a number. So if I run this just having return A minus B, because subtraction doesn't make sense on strings, it only makes sense for numbers, JavaScript will take each thing, turn it into a number, run that subtraction, we actually get the correct sorting result. So this is one way that we can do a comparator function. Remember that we're still dealing with a computer. Suppose that we really want to screw with the computer. So here I've got a comparator function, and I'm just going to return some number at random. This is perfectly legal. I can run this perfectly well, and the results make absolutely no sense whatsoever. Anything that you want to do in your comparator function, and in fact in your key selector function, is perfectly valid. Python, JavaScript are not going to care. For Python, it's just going to use that result and say, okay, rather than sorting it, this dictionary, this list, this whatever it is, whatever that entry is, I'll just pretend it's this result and sort it that way. For JavaScript, it's just going to say, okay, for these two entries, I got a negative number back. Therefore, whichever one I passed in first, that has to appear earlier. If the results don't make sense, if the results are random, it will run perfectly well. You just get absolute garbage out as an outcome, right? There is no requirement about how you write this comparator function other than it has to return a positive, a negative, or 0. So one last sort of example, and to show you the power this has. So I'm again going to go back to my example with the students. Right, so we've got these students, they've got names, ages, whatever else. Suppose that I wanted to do some ordering. As you may recall, in Python, if I had to return a single value to do all the sort of comparisons, and this became a problem. In JavaScript, we only have to return a negative number, 0, or a positive number. So we can actually write a more in-depth type of sort. Here I have this sort name ordering, and what I want to do is actually do the name ordering properly. I want to say, well, let me first do the name ordering by last name. So I want to sort everybody by their last name. To do that, it's relatively simple. I can say, if A's last name is smaller than B's last name, A should come first, then I'll return a negative 42. If A's last name is greater than B's last name, then I need to return a positive number. And if any of you are fans of bad 80s pop music, you might recognize 8675309 as the title of a song or part of the title of a song. It doesn't really matter what number I return as long as it's positive. Now, what if the two last names are equivalent? If it's not greater, not smaller, well, that means that they're the same. In that case, I want to use that first name to break a tie. One of the things that JavaScript does, this comparator function does, because it really just compares two things head to head, as it were, we can write as many different tests as we want. So I can say, okay, well, if they're still tied, then what I'll do is I'll compare the values of their first names. If A's first name should appear first, since their last names are equivalent, I'll return a negative number. If A's first name should appear second, I'll return a positive number. If both their last names and their first names are the same, I can just say, look, they're equivalent. I'm not going to worry about it. And so in this case, if I run this, you can see that, I can sort them. If I try to sort them without just calling that sort function initially, let me actually redo this real quick. Wrong comment. If I just call sort, JavaScript's not going to crash, even though it doesn't know how to sort dictionaries. It just doesn't do anything. So after I sort them using that name ordering, we have them ordered. So we have last name Fable, then Meal. Then we have the two Smiths. But note that since F comes before S, Fran Smith comes before Sal Smith. Then we have a W, then we have a Z. So when it can, because this is how we told it to do it, it's sorted by last name. When and only when the last names were equivalent, only when we got into this else, it sorted them by first name. If we wanted to make this even more difficult, suppose that we've got two Fran Smiths. I'm going to make one older. We'll make 123 and 145. Suppose that we wanted to sort by last name, then by first name, and then by age. Remember, we couldn't really do this in Python. We couldn't combine sort by numbers and strings. We needed that one return value. We can do this in JavaScript using these comparator functions. What we can do is, again, I'm going to use that subtraction trick. Say, well, if they're equivalent, if their last name is equal, their first name is equal, we can sort them by age. Right? And when I subtract them, it'll do that. And so as a result, when it does this, now note that I have two Fran Smiths. I have two that are equivalent, but no matter what happens, so right now I ran it with the younger Fran Smith being first and they were still first afterward. If I move them to being after that other Fran Smith, so the 45-year-old is first in the original array, then the 23, it still sorts them properly. It's able to sort them using as many fields as we want, as many types as we want. It just uses the result of that comparator function. So hopefully this gives you an idea of how we can do all of this custom sorting. We can, use it to compare strings or numbers or dictionaries, objects, or lists and arrays of lists and arrays, whatever we want to do. Any questions about how all of this works? Any other questions for me? Okay. I don't see anybody having any questions. So thank you all very much. We're going to talk more about how this sorting actually occurs inside of Python and JavaScript, and start thinking more algorithmically, start getting you thinking about what you're going to need for debugging bigger pieces of code, like the project, particularly part 4, for doing more coding, bigger coding, like you're going to be doing in 1.16, thinking about how we analyze these algorithms, like you'll be doing in 191, and more of that actually on Friday. So thank you all. Make sure you stay safe. Make sure you stay healthy. If you have any questions, please feel free. I have office hours in about 10 minutes. TAs have office hours around. There's always Piazza, which is back up. And thank you all. Talk to you on Friday.